Hi, welcome to the Raised Beaches podcast, a podcast about past climate, sea level, and global change. I'm your host, Dr. Evan James Gowan, but you can call me Evan. Today's episode is episode 8, and for today's episode, I'm going to try something a little bit different than what I've done before and discuss a profile of a famous scientist. And before I start that, I might as well give an update on what I've been working on in the past month since the last episode. And so today's episode is on July 15th, 2026. So it's been about a month since the last podcast, and I've been working mostly on investigating what the past literature, the past studies on Kikaijima, the island in southern Japan where I work at the Kikai Institute for Coral Reef Sciences. So one of the things that I've found really interesting is about how there was this famous research scientist on past sea level who's named Paolo Antonio Pirazzoli, whose first paper was actually on Kikaijima. So I thought it would be interesting to sort of go and look back at the history of this very famous paleo sea level scientist. Paolo Pirazzoli, he was born in Italy in 1939, and sometime in the 1960s, he moved to France to work as an engineer. But I guess things didn't work out with that job so much. So he eventually decided at 1968, by the looks of it, to pursue a PhD at the University of Paris. And he graduated in 1976. It's kind of, my PhD did not last that long, but in the past, it wasn't so uncommon to have a PhD that lasted on the order of 8 years. And the thing about Pirazzoli is that his work sort of led to the foundations of how we investigate past sea level, and he really emphasized the rigor of measurements and making sure that there's proper analogs for how, like, the geology of the past sea level indicator relates to the modern coastline, so that you can get a precise estimate of what the past sea level was. So Pirazzoli had a very extensive collection of papers that he's wrote over the years. And even when he passed away in 2017, he was still working on additional papers. So he was a coastal geomorphologist. So what is a coastal geomorphologist? I'm personally not a coastal geomorphologist, although I sometimes go out in the field. And a coastal geomorphologist studies the superficial geology and landforms that are shaped by the actions of ocean water at the coast. So in general, you think about like waves. So waves, generally speaking, are driven by the wind or storm surges or simply just tidal action. So at a lot of coasts, you'll find there are beaches. So beaches form sort of between the lower level of the tidal range and the upper level of the tidal range. So they generally can be used to, if you find a beach that's above the present day sea level position, you can use that to determine what the past sea level position, if you can find something within the beach to date. So another thing which is very important in the southern Japanese Ryukyu island chain is beach rock. If you go to Okinawa, there's usually this cemented rock that you find along the coast and beaches. The beach rock is usually full of fossils and stuff, and it's a cement, so it's basically cementing all of these fossils together. So you'll find like coral fossils and shell fossils. The beach rock is formed by a chemical process from urea. Yeah, urea is the same chemical that you find in urine, but along the coast it's produced by certain types of bacteria. It produces a very hard rock that forms sort of around the tidal range, so it can be used to determine past sea level. Another thing that Pirazzoli himself worked a lot on was notches, and specifically notches. I'll discuss this maybe in a little bit, but notches along a rocky coastline, you'll often see that there's a gouge in the rocks, in the cliffs. Especially true if the rocks are made of carbonate, and that is usually related to the tidal range. Another thing you'll find, especially here in Kikaijima, are terraces. So basically, you'll have the wave action and the tides, and that sort of wears away at the coast. So in areas where sea level is kind of stable, it eventually sort of creates this flat planar surface, which is known as a terrace. Kikaijima has plenty of these terraces that are formed by the coral reefs. Don't necessarily have to be coral reefs, but you can use them as an indicator of what the past sea level is if you do a nice survey of that. So Pirazzoli, like I said, he's a very prolific author. I tried to download a whole bunch of his papers, and I found over 160 papers that he was an author on, and over 85 papers he was first author on. His publication spanned between 1974 and 2017. It's a very long period of time to be publishing, and can only hope to be so prolific. And I say more than because there are definitely papers I could not find to download, and I'll talk about some of those along this podcast. In terms of where he did his work, a large proportion of his work was focused on the northern Mediterranean, from France to Turkey. That kind of makes sense. He's from Italy and France, so those two countries are sort of in the Mediterranean, but he also did a lot of work in Greece, and I'll talk a bit more about this later. He also did work in Iran, French Polynesia in the Pacific Ocean, the Seychelles in the Indian Ocean, Sumba Island in Indonesia, and also, which is relevant to what I'm working on, Japan and Taiwan. So he was all over the world and did a lot of interesting foundational papers on past sea level in those locations. So from what I read, his main motivation to becoming a coastal geomorphologist was that he went to some presentation on the risks of sea level change on Venice. So Venice is in Italy. It's very famous for its canals, and because of its connection to the Mediterranean Sea, it's very vulnerable to the hazards related to sea level change. This really motivated him when he saw these presentations where they were not being very precise about the hazards related to sea level change in Venice. So as a result, he did a lot of work, and one of his first papers was on Venice, but throughout his career, he did various papers about Venice, and even had one where he was criticizing the Italian government's measures to protect Venice from the risks of sea level change and storms. So that was a big part of what motivated him to become a sea level researcher. So his PhD thesis focused on the past 2,000 years, and during his PhD, he spent a lot of time in the Mediterranean and in Japan. So he used those two locations to try and deduce what the fluctuations in sea level have been since 2,000 years ago. And this really brought about one of the big archaeological-based sea level indicators, which were these Roman fish tanks. So there was a period of time about 2,000 years ago when it became fashionable for the Roman aristocrats who lived along the coast to build these large tanks that were connected to the Mediterranean, and they could be filled with fish so that they always had a supply of fish for banquets. And these fish tanks have kind of been, I only have a superficial knowledge of it, but there's a large literature on the interpretation of these fish tanks and their relationship to what sea level was 2,000 years ago. It was kind of a fad, these fish tanks, so they were only constructed for about a 100-year period. But along the coast of the Mediterranean, the Romans were all along there, so these fish tanks were all over the place. And in some places, they are uplifted and not connected to the Mediterranean anymore. And in some places, they are submerged under the water. And how these tanks operated is that they had a gate which would allow water to get into the fish tank, presumably at high tide, but it was high enough that the fish could not escape. So that would really narrowly define where they could be built and therefore what the sea level was at that time. So Pirazzoli's PhD thesis, which unfortunately there's not a digital version of it online, really emphasized that no place in the world can be assumed to be measuring the global average sea level, because basically there are fluctuations even in the past 2,000 years of sea level. You have to be very careful on assuming that the place where you're doing your field work is actually stable and not subsiding or uplifting. And that was a very important observation, especially in the Mediterranean and in Japan, where there's a lot of tectonic action that is causing vertical land motions. Another main topic of Pirazzoli's research was on these notches, which I mentioned before. And specifically, he was looking at tidal notches. And what a tidal notch is, basically, through the day, you'll have tides due to the interactions of the gravity of the moon and the sun. In places where the rocks along the coastline are made of carbonate, there will be an erosion that mirrors the tidal range. And the reason this happens is that the carbonate is not eroded due to like scraping of the rock by like sand in the water or anything. It's actually eroded because the carbonate rocks serve as a host for these bacteria that will sort of dissolve into the rock a little bit. And what happens is you'll have sea urchins that'll come along and they'll eat these bacteria that are in the rock. And because the sea urchin's beaks are harder than the rock, it will sort of wear away at the rock. And you'll get these tidal notches, and the deepest part is going to be where the mean sea level is. And the upper and lower parts of the notch represent the high and low tide positions. So based on the shape of these notches, you can deduce what the past sea level was if these notches are above the present day sea level. The thing is, though, that this only really works well in places where the notches have been uplifted tectonically, in places where the tectonic uplift rate is not so high. You'll get multiple notches forming, and then therefore it can be a bit hard to deduce the past sea level. In the Ryukyu Islands, where I am, especially in places like Okinawa, you see these really deep notches, and if you can find something to radiocarbon date, because the notches themselves cannot be dated you can use that to determine what the highest sea level position was in the Holocene. I'll talk a bit later about it, an example of that in Kikaijima. Another part of Pirazzoli's research was on the tectonics on the eastern Mediterranean. He especially was looking at Greece and Crete and Turkey. In some of these areas, there's been a substantial amount of tectonic uplift due to earthquakes. And one example that I found was in the western part of Crete. In the past 2,500 years or so, there's been, in some places, 6 or 7 meters of uplift. And using the sea level indicators that he investigated, he was able to determine the relationship of different earthquakes and relative sea level change. So, yeah, there's a lot of earthquakes. There's also volcanoes can also be involved in this in some of the locations. So, did plenty of field work in lots of different places in that area. Another big thing that Pirazzoli worked on was the International Geological Correlation Program, Project 200, it's IGCP, which was called Sea Level Correlation and Applications, which Pirazzoli led between 1983 and 1987. This project was sort of born out of an earlier project that happened in the 1970s, where, as a result of the research that Pirazzoli and others did, as well as the emerging evidence of the non-uniformity of sea level changes due to glacial isostatic adjustment, which I talked about in the first episode, it became clear that if they wanted to deduce what the global average sea level was, they needed to collect information from all around the world. So this IGCP 200 project really brought together a lot of sea level scientists to collect the information on past sea level using these very rigorous techniques that Pirazzoli advocated for. The conclusion, of course, is that there's probably no place on Earth that precisely measures the global average sea level. One of the really big outputs of this project was Pirazzoli's book, which was called The World Atlas of Holocene Sea Level Changes, which was published in 1991. Another thing that he mentioned at the end of this project was that at that point it was still not clear if sea level was rising due to human activities. He really emphasized that the models suggest that due to anthropogenetic warming, there is an expectation that the sea level will start to rise. 15 years after the project was over, Pirazzoli did publish that, it was becoming clear that sea level was starting to rise. So that sort of motivated some of his later work, which I'll talk about in a minute. Another big place where Pirazzoli did research was in Sumba Island, which is in Indonesia. And on this island, there's a series of coral reef terraces. And similar to Kikaijima, the island is uplifting tectonically at a fairly rapid rate. But the thing about Sumba Island is that it's existed for a lot longer than Kikaijima. And based on his surveys there, they deduced that the highest point of these terraces correlate to a past sea level high stand, maybe about 1 million years ago, and that these terraces sort of correspond to periods known as interglacials, where the volume of ice on the surface of the Earth is at sort of a minimum. That area has been investigated later on with new techniques, but that was a very foundational paper to understand that sea level high stands do correlate with the ice age cycles or the glaciation cycles. Another place that Pirazzoli did a lot of work was in French Polynesia, which makes sense. He was based out of France, and it probably was quite easy to justify going to these islands in the Central Pacific. He did a lot of work on coral atolls. So Coral atolls are usually these ring-shaped islands that usually have a lagoon in the middle. And what he found is that most of these atolls in the Pacific have had a period of time when sea level was slightly higher than present. That can be on the order of 1 to 2 meters higher. From my own experience doing modeling of sea level, that this does make sense in terms of the glacial isostatic adjustment. So basically, there's changes to the volume of the ocean due to changes in the shape of the Earth as the Earth continues to rebound after the melting of the ice sheets. And that caused the water to sort of be attracted to the North Atlantic and caused the ocean water in the Pacific to go down a little bit. Pirazzoli did work on quite a few of these little atolls in the Central Pacific. So another place that Pirazzoli did a lot of work was in Iran, specifically in the Strait of Hormuz. So if you've been following the recent political stories, Strait of Hormuz has been in the news quite a bit, and Pirazzoli did a lot of work there, specifically on an island called Keshem Island. And on this island, there's raised coastal deposits there. And he found that they dated to the last interglacial and the penultimate interglacial. He found that there was sort of a long-term uplift rate that was consistent with about 0.2 millimeters per year. Of course, probably couldn't go there now to do research, but luckily he was able to get there before things kind of went downhill. The last thing of Pirazzoli's research was on storm surges, and this was a bit of a change for what Pirazzoli had been working on for most of his career. And from what I've read, after he retired, he decided to get involved in coastal hazards, and that led him to doing research on meteorology and recent tide gauges. Probably this was motivated by his original interest in determining the hazards for Venice. As an example of one of the papers that I read that was quite interesting, is he was looking at storm surges due to large storms in northern France and in the English Channel, and he found that they got a bit lucky because some of these really major storms happened when the tide was low. So basically, he said, in the next time, they might not be so lucky, and these storms could be a lot more damaging than what they expect. And he was also doing some work on investigating if patterns of wind had changed in Europe in the past few decades. So he was trying to look for a climate change signal in terms of the wind patterns, which ultimately are what affect coastal hazards. And of course, I'm based out of Japan, and I am looking into what Pirazzoli did while he was in Japan. In 1978, as a result of his PhD work, he created this really large database of Holocene sea level changes in Japan. He was, of course, in his thesis, really interested in the past 2,000 years, but the Holocene sea level record in Japan goes back as far back as 10,000 years ago. And one of the common themes in Japan is that there's this so-called Jomon transition. So in ancient Japan, there was this Jomon culture, which existed over 2,000 years ago. And pretty much everywhere in Japan, sea level was relatively higher than it is now. Before Pirazzoli's paper, there was kind of debate about the reason for that. He collected data from sites at about 100 places, which also included Taiwan. From my investigation, it appears that he probably went to most of those 100 sites. Based on the photographs that I found that he took that are online, he did a lot of traveling. I think he was in Japan for about 2 years, and this was the first really major synthesis of sea level changes in Japan. there are all these pictures that he took, not just on coastal features, but also, like, for instance, he went to Mount Aso, which is the volcano in Kumamoto that I often have gone to. Yeah, he went to places like the Kii Peninsula, which is in Wakayama, which is south of Osaka. The Osumi Peninsula, which is in Kagoshima. It's really one of the southernmost places in Kagoshima, and investigating the coastal features there. Another place he went to was Tosa Shimizu, which is in Kochi and Shikoku. So last year I went on this cruise that stopped at Tosa Shimizu, and I remember going there and like being amazed that there was this very clear terrace there, which you could see. And Pirazzoli went there and he measured the height of that terrace, and he determined that this terrace was due to about a half a meter uplift from an earthquake that happened in the 1940s. So it was interesting to find this photo of it. So I was at this place, so I went to one of the places that Pirazzoli went to. Another thing that he published, he did a lot of work on these marine notches, like I mentioned before, but he also was using barnacles as a indicator past sea level. So barnacles, they'll grow on rocks and boats and anything that's pretty close to sea level. And based on his observations in the Ryukyu Islands, the barnacles tend to live within the tidal range, and they're easily eroded off the rocks after they die. So in places that have been uplifted, you can take those barnacles and measure what past sea level was within the tidal range. So that was one of the foundational papers on using modern analogs to determine past sea level. Another location he published a paper on was Taramajima, which is situated between Ishigaki Island and Miyakojima, and these are two of the southernmost islands in Japan. He found that there was a sea level high stand of about 1.5 meters that happened sometime between about 5 and 2,000 years ago. And this was based on the field work he did there. He had some other studies, which he was not first author on, that also investigated other islands in the Ryukyu Islands. So most of his work outside the Ryukyu Islands is not published in journals. So it's probably all in his PhD thesis, which I don't have access to. So I'm hoping that I can eventually get access to that. And I'm in Kikaijima, which is in southern Japan and part of the Ryukyu Islands. And from what I can tell, Pirazzoli visited Kikaijima twice, sometime between 1973 and 1975. And one of Pirazzoli's first papers was on Kikaijima, actually. So I think he had a paper on Venice and a paper on Kikaijima that were published in 1974. The paper on Kikaijima is called Terrasse Marina Kikaijima, Japon, which is in a journal called Photo Interpretation. And I'm saying that in a French accent because this is from a French journal. I also don't have access to this. This journal's not online, at least not from the 1974 issue. Unfortunately, I'm not able to access that paper, but he did publish some stuff on Kikaijima in his other papers. So, for instance, he had a paper that sort of summarized different kinds of sea level indicators, so proxies for past sea level. And he included a picture of the Kawamine Terrace, which is this really prominent coral reef terrace that formed about 50 to 60,000 years ago. He had a picture of it, and that terrace hasn't changed a lot since the 1970s. So it was kind of nice to see that Pirazzoli was in one of the more famous places on the island. Another example of a sea level indicator, which were the surge channels. So What a surge channel is that on the edge of a coral reef that's on the side of an island like Kikaijima, you'll find these channels. So basically the coral reef looks like a bunch of fingers jutting out. And these surge channels, it's not well understood why they form, but it could be a consequence of the wave action due to tropical storms. So it's basically a way for the coral reefs to prevent damage due to storm waves. And in the northern part of Kikaijima, there's some of these surge channels that have been uplifted out above the present-day sea level. And he said, these can be used as a indicator of past sea level if you are lucky. He suggested that these ones that he found in the northern part was evidence that there had been recent uplift. Another place where he went was this place called Iraqi, which is in the western side of the island. And if you come to Kikaijima, it's one of the most beautiful places on the island. There's this hiking path, and you can see the uplifted coral reefs. And in the winter, you can apparently see the whales that are migrating from up north during the winter. In Kikaijima, there's traditionally thought to be 4 major earthquakes in the past 7,000 years because there's 4 of these coral reef terraces. So the terraces are quite prominent. So the hypothesis there were 4 big earthquakes, but Pirazzoli also noted that there are these notches in the side of the rock that are above the 3rd highest terrace. The presence of these notches is also evidence that there was a major earthquake because these notches are preserved. So the tidal range in Kikaijima is a bit over a meter. So you need at least a meter of uplift to preserve these notches is the way that they are. So a couple of weeks ago, I went to this location and I got a picture of these notches, and sure enough, you can see these notches, and two of them are quite prominent, and because of their elevation, it's probably evidence that there's not 4 big earthquakes here in Kikaijima in the past 7,000 years. There are probably 6 earthquakes. So this research by Pirazzoli is perhaps not so widely known because the paper he discussed this in was published in this obscure French journal in 1974. So I'm really hoping to get this journal and investigate this a bit more. I want to go back to the locations where Pirazzoli went, as I did 2 weeks ago. This rock, which it's still there, but comparing the picture that Pirazzoli took and what it looks like now, the rock has been modified a bit. So they built a staircase so that you can go on top of the rock, and it looks like a chunk of the rock has been, like, it must have fell down, and there's a giant crack in it. So I'm going to try to advocate that we need to protect this rock a bit better because it provides evidence that there are 6 earthquakes. These notches are very common, especially if you go to Okinawa. Like in Okinawa, they're everywhere. But in Kikaijima, there's not so many notches that are preserved because there's not so many places where there's like a rocky cliff that can be eroded. Yeah, these notches are formed by biological action. They're not eroded directly by the waves. It's just fascinating to find out that Pirazzoli was on Kikaijima and he did a lot of work here. Pirazzoli passed away in 2017, which was before I was really a big sea level guy, and I feel kind of sad that I wasn't able to meet him. I don't really have any personal connection to him aside from my work when I was in Germany, where we were working on the World Atlas of Last Interglacial Shorelines, which we were compiling global information on paleo sea level in the last interglacial about 120,000 years ago. And the name of this atlas was directly inspired by Pirazzoli's book on the Holocene. I think maybe because of his engineering background, he really pushed for kind of a standardization of how to present past sea level data. Yeah, he had a very productive career, and from all the accounts that I read, he was very well liked and very personable. I do want to investigate a bit more on what Pirazzoli has done in Japan, because that's the topic that I'm working on right now at the Kikai Institute of Coral Reef Sciences. I do hope to find his PhD thesis. It's a bit tough to find these things while on this small island that's and our institute's not connected to a university, so sometimes it's a bit challenging to find all of the papers that I'm interested in looking in. So I found it interesting to look a bit into the career of very famous scientists like that, and I can only hope to have a similar impact that he had on the paleo sea level community. So the first thing, though, is, of course, you need to read what was done in the past so that you can make new contributions to the science. So if you're a budding scientist, really you need to spend some time reading these papers to really become inspired by what these big scientists did in the past. So anyway, I'm going to wrap that up, and I hope you enjoyed this overview on Paolo Pirazzoli. He was a very productive scientist, and I hope to read more of his papers because he was very thorough, and I enjoy that. I enjoy his level of thoroughness, and I look forward to reading more of his work. All right. Until the next episode, have a good summer. Thank you for listening to the Raised Beaches podcast. If you enjoyed this, please follow my social media accounts, where I post more information on the paleoclimate sciences. I am on Mastodon with the username @DrEvanGowan@FetiScience.org. On Bluesky, my username is @evangowan.esky.social. On LinkedIn, my username is Evan James Gowan. I hope you tune in next time. Thank you.